Okay, now I'm doing the dividing rule for radicals. And up top here you can see that I have a rule called, this is the dividing rule. Basically it's saying that if I have the nth root of a and I divide it by the nth root of b, it's the same thing as taking the nth root of a divided by b. So you can do that kind of idea anytime you want to, anytime you think maybe that could kind of simplify things. So for instance, this guy in disguise is really the square root of 6 divided by 3, which is the square root of 2. And you're done. Okay, this one would be the square root of 5/10, which reduces down to the square root of 1/2. Okay, whoops. Which means I have the square root of 1 over the square root of 2. Now, this takes a little bit of work. Okay, whoops, that's an equal sign there. Not always the easiest thing to use this thing. Alright, the square root of 1, I'm using up this room here, but the square root of 1 is 1. And then I've got the square root of 2. Now, the idea with rationalizing the denominator, okay, whoops, is that it must, you must get rid of the square root on the bottom. And in order to do that, all you have to do is ask yourself, how many groups does it, how many does it take to be a group to come out, and how many do I have? Well, remember, if you see a square root, that's always a 2. Okay, so there's a 2 right here. Alright, so that means I need 2 groups of 2. So that means that I need to multiply the bottom by the square root of 2. Okay, so now I have 2 groups of 2 that are now going to come out. Alright, but whatever you do the bottom, you got to do the top to keep your fraction equal. So anyway, these two guys come out, so now it's a 2. And these I can't do anything with, so my answer is 2 square root of 2. Okay, last one I'm squeezing in here, but okay, so if I reduce both those, you can imagine you're going to get, let's see, if you hit math enter on that, you're going to get the square root of 5 over the square root of 4. And if you think about it, the square root of 4 is 2 times 2, so got a pair, right? So that means it's coming out. And I don't have to worry about rationalizing the denominator because the bottom worked out to be a nice, perfect square. Alright, let's do some more. Okay, next one. Now we got some variables in here, got some numbers on the outside, so what do? Well, if you think about that whole idea that we can reduce things within a big, huge square root here. Remember, these guys are on the outside, these guys are on the inside. Remember, don't mix the two. So if I simplify this, I would have 4 over 3, again. Extend that a little bit. And then if you picture the whole square root going over this entire thing, okay, I can actually reduce these two. So really I have the square root of 4 over the square root of 5 because the n4s drop out. Okay, n4 divided by n4 is 1, so that drops out. So my top now, remember this is really 2 times 2 in disguise, so 2 is going to come out and multiply by that 4. The square root of 5 can't do anything with yet, so right now I have all the space, so I'm going to use it up. 8, 3 square root of 5. Now remember, you're not allowed to leave a radical at the bottom. Remember that I have an index number of 2. Okay, so that means I need another pair of 5s, another 5. Stop doing that. Stupid palette thing. Alright, so I multiply the bottom by square root of 5. Since this bottom's got the square root of 5, so does the top. So the top's easy. The top's just 8 square root of 5. And again, don't multiply the 2 because the 8's on the outside and the 5 is on the inside. Now, we've got these two 5's that are now freed. Yay! Free at last. But remember, I still have... Why does it keep doing that? I still have a 3 from before. So my final answer is 8 square root of 5 over 15. Remember, when you're doing the tops of any fraction or the bottoms of any fraction, that's multiplication if you have any extra numbers, like that 5 and that 3. So the whole process is multiplication. But we'll just keep going. Okay, next one. Alright, so if you can visualize us dividing all this out, this is what's going to happen. So if I cancel stuff out, kind of think of it this way. This is really a 1 power. Okay, so that means I can cross this one out with this one. Remember divisibility rules, when you divide you subtract. So if I subtract my x squared minus x1, I'm going to get 1. And I started on the bottom when I did my subtraction, so that's where my answer will go. Same thing here. I start with y4, I subtract 2. That gives me 2, but I started here, so this is going to end up being a 2. Alright, so now I have, and now it looks kind of ugly, but I now have this. 2, that's gone, isn't it? Let's see, where's my eraser? Okay, this is not here. Okay, so I have, looks like on the top, a 2, nothing, just a 2. So variables are out of here. At the bottom I have a 5, an x, and a y squared. Now, look at that really carefully. Remember that my whole idea is to get rid of anything that's a square root. Well, I've already got something here that can come out already. I don't like that color. Let's do this color. Right here. Remember, this means that I have 2 of them. And that's all I need to come out. So y is going to come out of this thing. And the rest of these guys are going to be stuck. So now, just to write down what I have, just so you can keep track. Right now I have this. Okay, because that y came out. Alright. So now the only thing I got to get rid of is the square root of 5. Again, I'm going to ask you, since we have square roots, how many do we need to come out? Okay, we need groups of 2. So that means, I'll use that time, is that I need a square roots on the top. So the 5 needs a partner, and the x needs a partner, so that the 2 of them can come out together. Okay, so now whatever I do the bottom, I do the top. My bottom now of this fraction is going to be a 5, an x, because remember they're now free, and the y that was already out there. And then the top here is just going to be the square root of 10x. Now, can I divide the top by the bottom? No, because this guy's on the inside and the one on the bottom is on the outside of a radical, so don't mix the two once you've got that thing simplified. Okay, gotta keep going. Okay, let's track to some higher roots. Alright, so right now I have, this is supposed to look like little fourth roots. I have a 4, I have a fourth root of 4, and a fourth root of 9. Unfortunately, there's nothing to reduce at this point. I can't even reduce 4 ninths. So I'm going to play around with this and do a factor tree. So that's a 3. But remember, I need 4 to come out. So I need 2 more 3's. So I'm going to do the fourth root of 3 times 3. So now you can see that I have, come on pen, 4 3's. Okay? And that's what you're supposed to be doing on this. So whatever you do to the bottom, you do the top. So I put a fourth root of 3 times 3, just so I can see it. Okay? And now I have to do is clean up. Okay, now the bottom should be fairly easy. Remember, I had a group of 3's that came out, and that's it. So the bottom's a 3. Top's going to be 4. Now, if you notice, I have a 4, a 3, and a 3. Even if I broke down 4, this 4 right here, into 2 times 2, I don't have enough to take out any group of 4. So I'm just going to multiply 4 times 3 times 3, which is 36. 36. And I'm done. That's the answer to the problem. Let me keep going. Okay, so again, I have this fourth root of 20 or fourth root of 22 of 108. So what I'm going to try to do, it might make my life more miserable, I don't even know. I like to reduce my stuff, so I'm going to reduce it by, let's see, will 4 go into it? 4 maybe? Let's see, this will be a 5. And 4 into this is 27? 27. Okay, so again, I reduced, remember your thought process is putting it all under one radical when you're reducing your fraction. Okay, you're kind of saying, hey, I'm going to try to reduce that. And I did. Makes the numbers a lot smaller, a lot less work. Okay, so now I'm going to look at 27. I'm going to split it up into 9 and 3 and 3 and 3. This is not going to be so bad. So right now I have 3 threes and I need 4 threes. So over here I'm going to write down my last 3 that I need. And when you do the bottom, you do the top. Okay, so now the top's going to come out to be 2 fourth roots of, again, you multiply whatever you got left on the inside, 15 over, remember I freed all of these 3's, all of them, all of these 3's. So all of this down here is just the 3. Okay, and there's your answer. Done. Okay, I got 2 more I think I gotta do. Okay, now let's throw some letters in. Alright, again I'll try to reduce that. Let me do that down here where I have some room. Okay, 10 over 135. That's gonna be, let's see if I divide by 5, that'll give me a 2 and a 17, no, 20. Alright, that'd be, if I divided by 5, it would be 27? Yeah, 27. Alright, there we go. And then again, think about your m's. Remember that you're going to take the highest exponent, which is a 3, and subtract out, don't forget there's a 1 there. So if I do that, then the m squared is going to end up being on the bottom. So this thing actually simplifies to be, let me fix it up so you can see. Okay, this reduces to 2 27ths. Okay, and then again, if I divide the m's, I'm going to have m squared left on the bottom. Alright, so now I'm just going to clean this one up, and again, I'm going to think to myself, oh, that's not giving me enough room. I'm going to think to myself, how the heck do I get rid of that denominator? So if you want to, again, at any time, just stop this video, try it yourself, and then, turn it back on when you're ready. Okay, so I've got the 4th root of 27m squared. So times, again, I'm going to split up my 27 into 9 and 3 and 3 and 3. And again, I need 4 to come out. So I need one more 3. And also, remember I need 4 and I have 2 m's, so I need 2 more m's. Okay, because I need 4 to come out. Alright, so whatever you do to the bottom, do the top. Okay, so your final answer here when you multiply straight across is the 4th root of, remember multiply all your insides, 6m squared all over, dun, 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 dun. Let's see, I took out a bunch of 3's and some m's, so I should have 3m, okay, because remember it took 4 of them, so there's 2 there and 2 there. So I'm taking out an m. Treat the m's just like they're numbers. So if you had 3 3's, you take out a 3. If you take, if you have 4 m's, you take out a 1m. If you have 4 3's, take out a 3. They work just the same way. But anyway, that's, whoa, let's not do that. That's your answer. Okay, do I have any more? Oh, okay, one more. Okay, so I'm going to reduce this thing down first. So I'm going to say this is the cube root of, and again, I'm thinking about cleaning up that bottom. So this is just 1/5. 1/5. The x squareds drop out, so I don't have to worry about those. And then I'm going to get a y squared on the bottom. Alright, well, I'm doing the cube root. The cube root of 1 is 1, so that's good. And then I've got this thing. This is actually going to be pretty easy, I think. Alright, so let me carry that down the bottom here. So I have 1 cube root of 5y squared. Now the nice thing about this is there's no factor tree. I just have to write down what I'm missing and I'm going to be good to go. Okay, whatever you do to the bottom, you do the top. Alright, so remember, I need how many in my group? I need 3 in my group. Well, I have 1 5, so that means I need 2 more 5's. 2 on the top, 2 on the bottom. This one I have y squared, that means I have 2 of them, and I need 1 more. So I'm going to put a y here and here. So my final answer is the cube root of 25y all over. Remember, these are free, so I'm going to get 5y. And that's it. So I hope this helped you out a little bit. It ran about 15 minutes, so I'm hoping that you got it.